The producer and a consumer relationship with the lock and condition interference. In this section, we're gonna discuss about the lock and condition interference. This interference gives you more precise control over the thread synchronization, but are more complicated to use. Any object can contain a reference to an object that implements the lock interference. A thread calls the lock its method to occur the lock. Once a lock has been obtained by one thread, the lock object will not allow any other thread to obtain the lock until the first thread releases the lock. If several threads are trying to call method lock on the same lock object at the same time, only one of these threads can obtain the lock. All the others are placed in a waiting state for that lock. When a thread calls method unlock, the lock on the object is released and the waiting thread attempting to lock the object proceeds. The class reentrant lock. It is a basic implementation of the lock interface. The constructor for a reentrant lock takes a Boolean argument that specifies whether the lock has a fairness policy. If the argument is true, the reentrant lock fairness policy is the longest waiting thread and it will occur the lock when it's available. And this is the main tip. Using the reentrant lock with a fairness policy, it avoids indefinite postponement. Means will avoid many postponements in a program. By using the reentrant, we can avoid it. And using a reentrant lock also, the fairness policy can decrease the program performance. When we can decrease also the program performance. If a thread that owns a lock determines that it cannot continue with its task until some condition is satisfied, the thread can visit on a condition object. It allows you to explicitly declare the condition object on which a thread may need to wait. For example, in the producer-consumer relationship, the producer can wait on one object and the consumers can wait on the another. But it is not possible when we use the synchronized keywords and an object built in monitor lock. Condition objects are associated with a specific lock and are created by calling a lock condition method, which returns an object that implements the condition interference. To wait on a condition object, the thread can call the condition await method. This immediately releases the associated lock and places the thread in the waiting state for the given condition. When a runnable thread completes a task and determines that the waiting thread cannot continue. By this, we can know that the runnable thread can call the condition, and it is a condition method signal which can allow a thread with that condition a waiting time. So it has a return to the returnable state. If the thread calls condition method, it is said to be a signal on, and when all the threads waiting for that condition, it is also known as a runnable state, and it becomes eligible to the reoccur lock. By this, we can also know about the await method, signal on method, which is used in a thread calls, means runnable state, immediate state, waiting state, and in all the conditions which I have learned previously. We already know about deadlock.